Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem is time needed to inform all employees. Let's go to the problem on LeetCode and try to understand what the problem is asking us to do. So it says a company has n employees. N is the number of employees that a company has with a unique ID, which is basically between 0 and n minus 1 now, and there is a company head. So I've drawn a company structure right here. So basically there's like big boss. It can be an employee itself, but then it has like some employee, and that employee has further employees working for under them. So they're like basically managers. Now what we need to find is there is an information that boss needs to pass down to all the employees, right? And they have given us manager array, which is basically is the node represent the node at index I represent the manager for that particular employee. So if employee is represented with index, then that value at that particular index, so like in first example at 0th index the value is -1. That means what? So employee 0, which is also the head of the company, his manager is -1. So which means they don't have a manager. They are the highest person in that company. Now what we need to do is they also have given us inform time array, and also just remember the manager array and inform time array, they will be same in length, and their indexes represent the employee ID or employee unique ID identifier, basically index, and the value represent who is their manager and how much time that employee takes to basically inform all the employees that are working for that manager. Okay, now so first example is quite really simple. They basically have just one person and they take 0 time to inform themselves, so they don't have to inform anybody down them. But the second example is quite important. It has basically the head of the company is number 2, basically index 2, and then there are 6 employees in the company. Manager array is given and inform time array is also given. Now let's try to understand the second example. So here we are given this particular array, which is manager. To create this structure, see, this structure is not given to us, we have to create it. And how we're going to create is we're going to create a dictionary, and we're going to call it company tree. Let's call it company tree. This will be a dictionary adjacency list that's going to hold manager index, and they're going to hold all the employees that are working for them. So this is our dictionary that we're going to have. So for first example, our dictionary will be basically, our dictionary is going to have who are the managers. Basically we can say just all of them are manager. It's just how many employees are working for them will differ. So 2 is a manager, and 0 is a manager, 1 is a manager, 3, 4, and 5. Now here if you see, it's only 2 that has all these employees under his management. So 2 doesn't work for itself, but 3, 4, and 5. But then these are empty. Okay, these are going to be empty. Then one more thing. We are also going to have -1 in the list, and that will be because -1 is the manager of head ID, which is 2. Okay, so that like our company tree is complete. We have to assign this because we will find this value when we are iterating over our managers. We will find this value, and while creating this tree structure, we have to fill in that value for each manager's manager or each employee's manager. You can just say whatever you like, but now how are we going to find it? The total time it takes to basically inform all the employees. So now we have created our company tree, and we're gonna use the algorithm BFS. We're gonna use BFS to basically find out how much time we're gonna take to send the information to all the employees. So let's say the boss start sending the information, and boss, let's say this boss takes maybe let's say 2 minutes. I think the unit here is given is minutes, so 2 minutes to inform all the employees. So this time till we reach all these employees, it's already been 2 minutes for each of them. Okay, now we're going level by level. Okay, so we to reach level 2, we can say, if boss is level 1, then we took 2 minutes for each of them. But these employees don't need to pass any further information. They're done right here, because they don't have any employees working for them now. But employee 1 has to pass that information down, and let's say employee 1 takes again 1 minute to pass down the information. So here the time will become 3 for each of these. Okay, and let's say for employee 4 takes like 1 minute or 2 minutes, so this will become 5 over here. Now what we're going to do is maintain, since we are doing level order traversal or BFS, breadth first search, we're going to basically append queue and the time that has already been taken to receive that information to that particular node. So boss basically we will add boss to the queue, or let's run our example over here. We have the tree, company tree data structure over here, and now we're going to basically start iterating over the tree. So we'll start with 2. We'll start with 2. So we come here, and then we know to receive information until 2 it's 0, but then 2 takes, which is over here, right over here, 1 minute to basically send information to all these tree. So it's basically once we reach all these nodes over here, we have already taken 1 minute. But then these employees, they don't have to send information further down, so we just return basically 1. We basically find out the maximum, because these nodes might have further employees 7 and 8, and this might have 6, but then this might take, let's say, 5 minutes to send the information over here. Then this will basically become 6 at this point time, and then this takes, let's say, 2 minutes. So then at this point it will become 3 and 3 for both of these. But the answer would be 6, because we have to calculate as per what is the maximum time whichever path, whichever employees or employee path is returning us the maximum time taken to inform the last employee in their this company tree hierarchy. Okay, so simple BFS, we maintain a variable total time taken, which will be 0 initially, and at every level we basically update it with the max, already seen max, or maybe whatever value it's going to return from bottom, and that max. So we're basically like calculating the max value and we're just passing it down to the nodes. So our queue data structure will not just contain only the just the node, but also the time that has already been taken. So as I said, what we're going to do is get the company tree first. So company tree basically would be a default dict, or I'm just going to create a normal dictionary that is going to have basically manager and all the employees working for manager next to it. For manager in range and is the number of employees. Now we're treating everyone as a manager, and even the least person in the company, you know, at the least lowest level, they might be a manager themselves, but they manage themselves. Okay, let's just say it like that. And initially the company head, which is -1, whose manager is -1, so we'll append this company head over here. Okay, company head is in works for -1. So for index and manager, let's represent his manager in enumerate manager. We're going to visit all the managers and manager array. So basically, and then for that particular index, so index in manager array, that particular employee at the index I or index, their manager is M. So I want to append in my company tree, for that manager, I want to append index, or instead of index, I'll just call it employee. You know, that makes sense. Makes more sense. Okay. All right. Now we have our company tree structure. Now we're going to create a queue that will have two values. First is the parent or the boss or the highest level, you know, the head ID, which is this, and then we're going to assign 0 to it because it has taken 0 amount of time to receive information from whoever is on the top of head ID, which is nobody. So we're just going to assign 0 here. All right, and then let's say total time so far is 0. Now we're going to basically iterate over all the elements in our queue so that we can process their employees and their employees or their managers or whatsoever, like whatever managers work for them, we're going to process that as well. So here, let's pop out the values from queue, which will be the first employee of the company, who is the head of the company. Now that head will basically, when we pop out, so it will be the head ID. So let's call it maybe node or whatsoever. Let's call it boss. And then we're gonna have time so far, you know, the time that has already been spent to reach the information to this particular boss. And we're gonna pop out q.pop, and let's do this 0 because I'm using like a, you know, the array data or list data structure here. I'm not really using DQ. Okay. Now what else? Now we have boss and the time that has been taken so far. Now I'm gonna call my employees, and I'm gonna ask them, you know, like to send the information to their employees. Okay. So I'm gonna call for employee in my company data structure of this particular post. Okay, and for this boss. So what's going to happen is I will now append, and here's the thing, I have to basically update this time as well. So what's happening is I will have to update this time, which is the total time, initially 0, but now it's going to be maximum of whatsoever has been calculated, and this particular time that has already been used while during this whole breadth first search, sending into time to information. And I'll send over here, like I'll update in the queue when I'm putting the employees or managers in the queue from front and popping out from the back. So I'll update that time as well. So here that will be the time. All right, now what? Now this employee is gonna be put into queue so that it can process sending the information to its managers, the managers that work for it, or employees that work for this particular boss. So queue.append, and we're gonna always remember that we're gonna send two values over here. First is this employee, and this employee is going as a boss now. Okay, it's going as a boss into the queue. It will be popped out as a boss. Now this employee, now we have to also send the time that has already been taken to basically send that information until here. So that will be the time that was already taken, which is this, by its boss, and the time that my current boss, basically my current boss is using to basically send the information to all its children. So that will come from inform time. Okay, that will come from inform time, and we're gonna put over here inform time. All right, and we're gonna send boss here. That's how boss, basically these are like indexes, right? So boss inform time has that value over here. Now we're going to basically simply just return total time. Okay, total time we're returning. Let's go over it again. This is just simply in the dictionary format. We are creating the company tree, which is adjacency list as well. Now every manager has a list of employees that's going to work for it. Initially company head is going to have, this is honestly, this is not even needed. It's just I could even skip over here whenever I see this -1, but like this makes more sense. If we print it out, then even the head also has like -1 as their head. All right, then we just start processing the head ID with time 0. Initially total time is 0. Then we keep processing all the nodes in the queue, which are like, and then we pop out the boss and time from the queue. That's what we put initially, the time that has already been taken by head until we reached head ID. And same, we're gonna process all the employees of in the company tree structure of the current boss that we are processing, and then we're gonna send the employees down to send the information to its children. We're gonna append in the queue so that we can process that further, and the time would be basically until, so the time that has already been taken above me, and then the time that I am currently gonna take, this current boss is gonna take to send my all my employees, that will be same, that will come from inform time. And then I just simply return the total time, which I have already updated here because I'm sending this time. Initially it would have been 0, right? Like it came from queue first and only element, which is the root element, and 0 plus inform time, that for this particular problem was 1, because we sent 2 at index 2 is 1, so it will send 1 over here, and queue has values, all these values, then it's gonna update this time. All right, let's zoom out and run our problem. Oh, not problem. Run our solution. All right, passes the test cases. Let's try to submit it. Honestly, beautiful solution. Makes perfect sense. Awesome. All right, let's write the time complexity, which is the number of nodes. We are processing each node once, and that is just pushing into code. Is all the BFS takes number of n, which is the number of nodes time to and from all the n, which is, you can call them nodes, you can call them employees in this case, you can call them the child, whatsoever. All right, and space complexity is going to be big of n as well, because we are storing it in our company tree. That's the max we can store. And also we're gonna keep putting things in queue. Usually queue is like the width of the structure. All right. Okay, let's go back to AlgoYogi and mark this problem solved. I'll see you guys in next problem in our tree series. But please give it a like, subscribe, whatever. I'll upload the solution here as well. Just make use of AlgoYogi. All right, bye-bye.